Hey, what's up everyone? Welcome to my channel Cyber Hashira. Today I'll be talking about a Java utility called Jarsigner. After a developer finishes coding a Java-based application, they package all their Java class files in an archive called jar. Jar is a short form for Java archive. Before distributing a jar file, it is preferred to sign it. This way, a developer can prove that it was them who wrote the code for that app and no changes were made to it from the date it was signed. Jar files are signed using a Java utility called Jarsigner. So in this video, I'll give you some basic information about a jar file. Then I'll show you how to sign a jar and verify it using Jarsigner. Let's do some code signing today. If you don't know what a jar file is, a jar file contains all Java class files compiled from a Java code. Jar is a short form for Java archive. A jar file uses zip format to archive all class files. A Java project may produce many class files when it is compiled. Packaging them as jar makes it easy to distribute them. Let me show you. I already have a very basic Java code on this machine which I will be using to build a jar file. So in my Dojo directory, I have a directory called Solar System, and inside this Solar System, these are my Java files. If I compile all of these Java files, it's going to produce 1, 2, 3, 4, 5, 6, 7, 8, 9 class files. Instead of distributing all those 9 files, I can simply package them into a jar file and just distribute one single jar file. So I have a script called build, which is supposed to compile all these source code and package them into a jar. Okay. Here's my jar file. I will move this jar file out of Solar System. So mv solarsystem.jar ... Okay, it's not here. It's here. Remember I mentioned that jar file uses zip format. So if I do unzip solarsystem.jar, check this out. It has inflated all the files that was stored inside or archived inside solarsystem.jar. So if I do ls, there's a com directory, there's a meta.inf directory. Let's go inside the com directory. There's Solar System. And these are all class files. All right, I'll get out of here. And I'm back to my Dojo directory. I'll get rid of com. I'll get rid of meta.inf. If I want, I can even execute this solarsystem.jar. Check this out. This is the output. I mean, this is what it's supposed to do. And that's the output I was expecting. Let me show you how to create a jar file. Now, just in case if you want to create your own jar file, let me show you how you can do that. So I'll create a directory called test. Let me go inside test. There's nothing. Clear the screen. Whatever I'm going to show you now is just so you could make your own jar files. So let me show you how to create a jar file using one single file. So I'll do echo. This is a test and test.txt. So I have a file called test.txt, which is just a text file. The command is jar-c. C is for create. F is the name of the jar file. So I'll name that file test.jar. And the file that I want to insert in this jar file is test.txt. When I hit enter, I get this test.jar file. Similarly, let me delete all of this, clear the screen. You could also use the same syntax of jar command to create a jar file using multiple files. For example, let me do for n in 1 dot dot 10 curly brackets semicolon do echo this is file $n, put this in file $n semicolon, done. All right, so I have 10 files over here. If I want, I can use that same jar command to create a single archive of all these 10 files. So it's the same command, jar-c for create and f for the name of jar file. I'll name it test.jar and I'll just use wildcard. So file asterisk, when I hit enter, now I have a file called test.jar. Let me remove all files. So we are left with test.jar. If I want, I can extract this file using jar file. So the command is jar-x for extract. F is the name of jar file, test.jar. When I hit enter, I get all my files back, including a directory called meta.inf. If you go into meta.inf, there should be a file called manifest.mf. This file contains information about the jar file. So the information, if you read this file, it's just a text file. So right now we have the version of the manifest file and also the version of JDK that was used to create this manifest file or create this jar. We could also include some other information such as class path, which is mostly included by some of the developers to include the dependent class files. Anyways, I'm going to get out of this and I'll just remove all of this. Sorry, recursive force. Okay, directory is clear. Now that you know how to create a jar file, I'm going to show you how to sign and verify a jar file. The simplest way to find out if a jar file is signed or not is by using Jarsigner command. So I know this file is unsigned. We just built it. So I'm going to run the command Jarsigner -verify solarsystem.jar. This command says jar is unsigned. Let's have a look at a jar file which I'm sure is signed. So I think that file is inside software, bouncy castle, PC proof, ext. I'll bring this file here. Okay, we got the file. I'll clear the screen. Okay, so Jarsigner -verify PC proof. And this one says the jar file is verified. By the way, Bouncy Castle is a security provider for Java. All security providers are signed. If they are not signed, then most installation of JDK or JRE would reject those jar files. All right, let me clear the screen. There's also an option to view a verbose output of Jarsigner verify. So for example, if I do Jarsigner -verify PC proof, and I can simply add verbose, and this should display a verbose output. Now these are all the class files that are inside the jar file. You would also notice that right next to the file names, there is S and M. Now, if you scroll down, here's an explanation of what S and M means. S means signature was verified. M means entry is listed inside manifest. Now, the way a jar signer or a signed jar works is every class file that exists inside a jar file, a hash of that class file is included in the manifest file. Once the hash of all class files are included in the manifest file, the private key of the owner is used to sign the manifest file. So when you see SM right next to a class file, What this means is the hash of this file exists inside the manifest file, and the manifest file itself was signed by the private key owner. And the owner of the private key is indicated by signed by. So signed by, this is a signer. You can see the common name as Legion of the Bouncy Castle. So we knew that this jar file was signed by the Bouncy Castle. A jar file is also time-stamped. So this is the time-stamping authority that actually time-stamped this jar file. And at the bottom, we see that a jar file is verified, along with some warning, which I will explain what it means. Let me clear the screen. There's also an option in Jarsigner to just view the summary of what it was able to verify. So for example, if I do Jarsigner-verify Bouncy Castle verbose : and just type summary, and this will just give me a summary of what Jarsigner was able to verify. So instead of displaying a really long output, here's the summary. So I see the signer's certificate, I see the timestamping authority certificate, I see that the jar is verified. There's also an option in Jarsigner, like when you use verbose output, you could also make it display the certificates. So you just need to add -certs at the end. And check this out. We see the certificates that were used for signing this jar file. All right, I'll clear the screen and let me show you how to sign a jar file. To sign a jar file, the first thing we need is obviously the key. So I already have a command that I'm going to copy from my notepad and paste it here. Let me explain this command to you. So keytool-gen key, we are going to generate an asymmetric key with alias signing key. The algorithm for that key is RSA with a key size of 2048. The signing algorithm that I'm going to use is SHA-256 with RSA with a validity of 365. The key store that I will be using is mystore.p12 of type PKCS12 with a distinguished name of signing key, and this is other information. I'm also adding some extensions. So we have a key usage, a critical key usage of digital signature. There's also an extended key usage of code signing and another key usage for basic constraint, which indicates that this is not a CA certificate. All right, I'm going to hit enter and I'll just enter some password. All right, let me do keytool-list-keystore mystore.p12 store type PKCS12, and I'm going to enter the password. Okay, so we have a key called signing key, and I will be using this to sign a key. But before we do that, the certificate that we have, let me do a verbose output. So -v, I'm entering the password. Now the certificate that I have here, this is a self-signed certificate. Although for testing purpose, it's perfectly fine, but in production or like when you're actually signing a code, it's always best to get a signed certificate. So instead of using a self-signed certificate, it is always best to get a CA signed certificate. So I'm going to do exactly that. I'll clear the screen. In order to get a CA signed certificate, we need to generate a certificate request. So I'm going to copy a command from my notepad and paste it here. So keytool-certrec, which is used for generating a certificate request. I'm telling certrec to use signing key alias from keystore mystore.p12, which is of type PKCS12. And the file name where I want to store my CSR is signingkey.csr or certificate signing request. I'm going to hit enter, and here's the password. Let me do cat signingkey.csr. Here's the certificate signing request. I'm going to pass this request to my local OpenSSL based CA and get a signing certificate. I'll pause this video now and I'll be right back after I have the signed certificate. I have my signed certificate now. Let me show you what I have. So my issuing.cer, this is my issuing CA. My root.cer, this is my root CA. Signingkey.cr, this is the signed certificate that I received from my OpenSSL based CA, and this is obviously my key store. So the first thing I'm going to do is I'm going to create a bundle of signing key, my root, and my issuing. It's going to be a PKCS7 bundle or P7B file. So I'm going to run the command OpenSSL crl to PKCS7 -no crl cert file my root, cert file my issuing, cert file signing key, and the output is signing, not singing, signing key.p7b. I hit enter. Here's my P7B file. Now I'm going to import this P7B file into my key store. So I'm going to run the command keytool-import cert-alias signing key-key store mystore.p12, and the store type is pkcs12, and the file that I want to import is signing key.p7b. I'm going to hit enter, and it's asking if I want to trust this certificate. I'm going to say yes, and certificate reply was installed. Let's do a key tool list. So keytool-list key store mystore.p12, store type is pkcs12, and I want a verbose output. And here's the verbose output. So let me scroll up. Okay, so my alias, the key alias that I will be using to sign my jar file is signing key. It has 3 certificates in the chain. The first certificate is this signing key, which was issued by my issuing, and if I scroll down I should see my issuing certificate, and if I scroll further down I should see my root certificate. Alright, I'm all set to sign a jar file. Let me clear the screen. I'll sign solarsystem.jar, and the command is jarsigner-key store mystore.p12, store type is pkcs12, solarsystem.jar, and the name of the key, which is signing key for my key store. Enter the password. Okay, I'm getting a message that says jar sign, which means solar system has been signed using my signing key. I am also getting 2 warnings over here. The first warning that you see here, this simply means that it cannot form the certificate chain. So remember, I have my signing certificate, then I have my issuer certificate and my root certificate. All of that is stored in PKCS12 file. However, when you execute Jarsigner, it expects those certificates in the trust store, which means in the CA cert directory. Now, because I don't have my issuing certificate and my root certificate in the CA certs, I am getting this error because Java is not able to form the certificate chain. The second warning message that I'm getting is about TSA. Now, Jarsigner will always recommend using a TSA, timestamping authority, to sign the jar file. If I don't use a TSA, I will see this error message. Okay, let me clear the screen. And so this is my jar file that has got signed. Let's try to verify it. So Jarsigner verify solarsystem.jar, and check this out. It says jar verified, and obviously I'm still getting those two warning messages, and I'll show you how to get rid of these two messages. Let me clear the screen. Guys, it's raining heavily outside. If you hear loud thunder sound, please don't mind it. I don't have a soundproof room. Anyways, let's continue. So where were we? I lost track of it. God, what am I doing here? I'm gonna enjoy the rain for now, and I'll continue later. See ya. Yes, it's raining. You like rain?
Yeah.
There is an option in Jarsigner by which you can create a separate jar file and leave the original file as it is. For example, when I executed the previous Jarsigner command on this file solarsystem.jar, it simply inserted the signature into this jar file, and that's it. It was considered signed. What if I don't want to touch this jar file? Instead, create a new jar file which is signed. So let me show you how to do that. I'm going to remove solarsystem.jar, and I'm going to go inside solar system, build a new one. Okay, I have my new jar file, and this is unsigned. Let me clear the screen. So the new command is going to be something like this. So it's jarsigner dash key store my store.p12 store type pkcs12, and then we have an option called signed jar. With this option, you can just give a new name that you want to use for a signed jar. For example, I can just say solar system, or I'll just use a short name. So ss signed.jar, and we have the original file, which is solarsystem.jar, and the alias, which is signing key. Hit enter, and perfect. Now it says jar file is signed, and if I do a long listing, I should see a new file. So if I do jarsigner verify on solar system, this is going to say unsigned because this file was never touched. And if I do jarsigner verify ss, and this one is signed. All right, let me clear the screen. I will now show you how to use a timestamping authority. So it's the same command, but we will use something new. So jarsigner key store my store.p12 store type pkcs12 dash signed jar. I'm going to name it ss2.jar, and we are going to use a new switch called -tsa. After TSA, we will have to put a URL. I already have a URL. I'm going to copy it from here. Okay, so this is a URL for the timestamping authority that I want to use. It belongs to global sign. Whatever timestamping request is generated by Jarsigner, it will be sent to this URL, and it will sign that request, send it back to Jarsigner, and Jarsigner will include that signature into the signed jar. All right. The original file, which is solarsystem.jar, and the signing key itself. Hit enter. All right, it says jar signed. Let's try to verify it. So jarsigner verify ss2. Perfect. We see the message jar verified, and I don't know if you have noticed this, we are not getting a warning for TSA anymore. Let me clear the screen and do jarsigner verify on the previous file that we signed, which was sign.jar. Okay, so over here we are getting two warnings. One of them is for the certification path, and the other one was the warning for not using TSA. And now with this new jar file, new sign jar file, I am not getting that TSA warning anymore. Let me do a verbose output, clear the screen. So dash verbose, and check this out. We have the information about the signer, and we also have information related to the timestamping authority. I'll clear the screen. Okay, so we managed to get rid of the TSA warning that we were getting for not using timestamping authority. Now let's get rid of this certificate chain invalid error message. I'm getting this message because Jarsigner was not able to form a proper certificate chain. There are two ways to prevent getting these warnings. So clear the screen. So I have my root certificate over here and my issuing certificate. Now I could simply add my root certificate and my issuing certificate into the CA-certs file. CA-cert file, as you know, is the trusted or the trust store of JDK. This file exists in the JRE libext directory. CA-certs holds all trusted root CA certificates that are coming from trusted certificate authorities such as DigiCert, Entrust, or maybe Global Sign, Microsoft. The certificates that I'm using, my root and my issuing, these are coming from an OpenSSL based CA, which I generally use for testing purpose. Now, I don't want to simply put those certificates into the CA certs file. So the second alternative that I have is I could just create my own trust store. And the way to do it is I could just do key tool dash import cert key store. I'll just name it trust store. File name is my root and the alias is my root. Password, repeat. Do you want to trust? Yes. Done. And similarly, I'll add my issuing certificate. So my issuing, and I'll change the alias, enter the password. Excellent. Let me do key tool dash list on my trust store. All right, so I have my two certificates as a trusted cert entry in this key store, and this key store is of type JKS. Now, if I include this trust store in the Jarsigner command, so if I do keys dash key store and trust store, check this out. Now I am not getting any warnings. We managed to get rid of TSA by using an actual timestamping authority, and we created our own trust store, and we were able to get rid of the certificate chain invalid warning message. And now we are getting a simple message that says jar verified. Let me clear the screen and I'll do a verbose output. Oops. It's verbose. So the jar is verified. We are not getting any warnings for TSA. We are not getting any warning for certificate chain. This is the certificate that was used to sign. This is the timestamping authority certificate. And here's the output. I don't know if you remember this, but we are now seeing a new letter called K. So previously we were just getting SM. Let me repeat that command with no key store or trust store. So this is the the message that we were getting. Obviously it has the warning, but we were seeing SM And now when we include our trust store, we are seeing SMK. And here's what K means. At least one certificate was found in key store. It means that I'm passing a key store and Jarsigner was able to find a certificate from that key store. So from this command, I am passing trust store as the key store, and I'm expecting Jarsigner to find all other certificates from that key store. Therefore, the letter K. That's all I have for you on Jarsigner today. I have included link to my GitHub page in the description from where you can view all commands I used in this video. I hope you found this video to be informative. Hope you learned something new from it. I would suggest you to try everything I taught in this video. Practice it by signing a jar file on your own. If you have any questions, then please use the comment section and I'll try to help you as soon as I see it. And thank you so much for watching this video. Please leave a like to this video if you liked it and subscribe to my channel if you haven't. I'll see you soon in the next one. Bye bye.